All right, so here we are. We're back to the light board with my light as it should be. I don't look like I'm just in a dark room of my house, which is where I'm at. Uh, so this is great. So let's go ahead and start with the problems for the review. So we're going to start with y double prime equals x sine x. Problem 1 is just verifying that a given function is a solution. I don't think I'm going to do that one just because it's very straightforward. So the first thing we're going to do here is we're going to do an integral. So y double prime dx is going to be the integral of x sine x dx. And this is going to just give us y prime. And now here I need to do an integration by parts. So I'm going to do u equals x. Did I go too high? Yeah, I think so. Yeah, u equals x, du is dx. I'm going to write dv a little bit lower here, which is going to be the sine of x dx. And then v is going to be the negative cosine. Oops, cosine. That's a weird cosine. Good enough. And so we're going to do our integration by parts is going to be uv. So negative x cosine x. And then minus the integral of v du, but I have a negative, so it's going to be plus the integral of cosine x du is dx. And that's going to give me a sine. I'm not liking this marker a whole lot. Let's try this one. Oh, better. Yeah. So let me cap this one. I'm going to go for my box of lost markers. I don't know why these neon ones go by so quickly. So the derivative, the antiderivative here is going to be the sine of x plus c, and that's going to be my y prime. So to get y, I'm going to integrate again. So when I integrate, I'm going to get y. I'm going to have to compute the integral of x cosine x. I'm going to write it here, and the integral of the sine as well. We're going to leave that room. Let's compute here. Same as above, u equals x, du is dx, dv is the cosine dx, and then v is going to be the sine x. And so uv is going to be here. I remember I have a negative, so I should write the whole integral here. Let's call this I. And so that integral becomes uv, which is going to be x sine x, minus the integral of v du. V is sine, du is dx. And that's going to give me x sine x. Minus here is going to be the negative, so plus cosine x plus c. I already had a c there for the first integral, so I'm going to call this c1. And for the second integral, I'm going to call that c2. So now I plug that in here. I'm going to have negative x sine x minus cosine x. That's going to be from this and this, right? And then I'm going to have to integrate this one again, and then the integral of the cosine is going to be negative. The integral of the sine is going to be negative cosine. So I'm going to have a minus 2. Ugly, but let's put it there. Now when I integrate this c1, I get c1x, and then I get a c2, the second constant. Let's see, I got the integral of this, and integral of this, and then c2. That's how you do it. All right, that was nice, but we had two double integrals, which make it a little bit, two integration by parts, rather, that makes it a little bit exciting. So, but that was it. The next problem is essentially the same, but I'll give you initial conditions. So I'll just give you the highlights as to how to do it, and then I'm going to move on to the next two problems. So I'll erase and I'll be back to you. I love how this looks. It's back to my regular light board. You don't have an idea how much it hurt me to record those other videos. Anyways, I'll erase. Alright, so I decided to against doing the e to the x because I want to focus on this. I don't think I'm going to have enough to do everything in one single video, but I do want to focus on something we talked about in class today, and I think it's very important for this exam. When you have equations linear equations that are homogeneous, meaning that they are set up equal to 0, then what you would normally do, I'm going to go in detail. There's two ways you could solve it. You could do the integrating factor. It's going to be overkill. What you could possibly do, or would be better to do, is subtract that linear term, or this term, on both sides to obtain this. This is a separable equation, so you can divide by y and leave this p of x here. Then you can integrate both sides, and this is going to give you a natural log of absolute value of y, and this is going to give you a negative the integral of p of x dx. And then you can exponentiate both sides. The absolute value is not necessary because this is going to be positive, because it's going to be an exponential. So you're going to have a that y is going to be equal to e to the negative integral of p of x dx, plus this is going to give you some constant c, and so I'm going to put it down here, if you will. I put it where it doesn't fit. Fail. Okay, there's some things that are user error that I cannot blame on the lights last time. There's some things that I just don't always look at my margins. So anyway, so you get that solution, and that formula you can always use. That's going to save you quite a bit of time. And in particular, because the next problems in the exam are going to be of this type. So I recommend that you just use your formula really to solve them. So let's go ahead and take a look at one of those problems. Let me erase, and I'm going to show you what we had. So the problem is something like this, if I remember correctly. X squared y prime plus or minus, I don't remember. Oh well, not that big of a difference. So the only thing that you have to do is rewrite your problem in the standard form. So divide by x squared on the whole equation, and then you get 1 over x squared y equals 0. So using this, then your solution will be of the form k e to the integral of negative, because p of x here is negative 1 over x squared. So negative just becomes 1 over x squared dx. And then you just integrate this one. And it gives you k, which is equal to e to, this is x to negative 2 plus 1, negative 1. So you're going to have negative 1 over x. Not plus c, because I already wrote it here when I gave you the general solution. So that was the problem in the sample exam. Very, very simple. So let me show you the next one where you have an initial condition. So in fact, if you were given an initial condition, something of the form, something, I cannot do y of 0, gotta be careful with that, but I could do something like y of 1 is equal to 3, or whatever you want. And so what you would have to do is plug in y of 1 would be k e to negative 1, and that you're saying is going to be equal to 3. So then you multiply times e on both sides, and you get that k, I still fit it, is equal to 3e. And then your solution for this initial value problem would be y is equal to 3e. Well, I'm going to have another e. So what I'm going to do, I'm going to put it together here. A plus 1 there. So because it would be a 3, 1e from this and then this. Whenever you have the same basis, you add the exponents. And so e to the 1, I just add the exponents. And that would be the solution to that initial value problem. So given that I summarized these two problems so much, I'm going to return to the one with the exponentials and the second derivative. So let me go ahead and show you how to do that one. You'll have to play mix and match with the review sheet I gave you, but you'll find them. I trust you will. Let me erase. We'll get back to it. All right, so let's take a look at this one. I don't know if these are the initial conditions, but why not? So we have again the case of a y double prime. So what I'm going to start doing is I'm going to integrate one time. So I get y prime is going to be equal to the integral of x e to 2x dx. That's an integration by parts, as we did before. U is equal to x e to dv is equal to e to 2x dx. Sorry about that mess there. Du gives you dx, and v gives you 1/2 of e to the 2x. So we're going to put this in here. Our first integral will give us ux, which is going to be 1/2 of xe to the 2x, minus the integral of v du, which is going to be, again, 1/2 e to the 2x, and then du is dx. And here, I'm going to have I'm going to integrate, and I'm going to do the plus c after that. So 1/2 x e to the 2x. When I integrate this one, it's a u substitution. U equals 2x. Gives me another 1/2, so 1/4. Oops. 1/4. I'll leave it as 1/4. E to the 2x plus c1. That's my first condition. What I could do is use this initial condition at this stage. So y prime of 0, this is y prime, remember? Y prime of 0 is 1. So when I plug 0 here, this one goes away. This one does not go away, gives me a 1/4. And plus c1. So I added 1/4 on both sides, and I get that c1 is equal to 5/4. From where I get that the derivative y prime is going to be equal to, let's factor that 1/2 of e to the 2x out of that. And then I'm going to have x minus 1/2 plus 5/4. So I just factored, because there's a 1/2 here. There's a I could have probably done a 1/4 and put this 2 minus 1, either way. But I had a common factor e to the 2x. That's the one that I really wanted to get rid of. Because then my integral, I don't have to deal with multiple integrals, just a single integration by parts. So when I integrate again, I get y is equal to, and I'm going to integrate here the 1/2, forgot about that, e to the 2x times x minus 1/2 dx. We're going to deal with that with an integration by parts. Now integrating this one is going to be a, can I fit it? Yeah, 5/4 of x. Again, if I fit the 4, if I actually managed to fit the 4th there. And then my integration by parts here is going to be the same, x minus 1/2 du is dx. dv is going to be e to the 2x. And then v is going to be equal to 1/2, well, dx, I should have said it here, 1/2 of e to the 2x. All right, so now my integral, here I plug it in, so I get 1/2 of uv, so uv is going to be another half, so it's going to be 1/4 of x minus 1/2 e to the 2x. That was my uv, minus the integral of v du, which is going to be 1/4, because I have a 1/2 here and a 1/2 here, of the integral of e to the 2x dx. I'm out of the room, of the light, of the board, oh my goodness, whatever it is, 5/4 x, and I still have to integrate this, and then I'll get an extra constant, and that's going to give me a 1/4 x minus 1/2 e to the 2x. This is going to give me another 1/2, so it's going to be minus 1/8 e to the 2x plus 5/4. That still fits, of x plus c2, and now we're going to solve for c2. So I'm going to erase this part, leave the problem, and then I'm going to get the solution. I'll be right back. All right, so let's go ahead and simplify this a little bit. So y is going to be equals, I want to factor this term, move it in here. So it's going to be a 1/2 minus a 1/2 is going to become a minus 1. So it's going to be a 1/4 of x minus 1 e to the 2x. And then I'm going to have the plus 5/4 of x plus c2, and I'm going to use my initial condition. y1 is equal to 2. y1, if I plug 1 here, this goes away. And then this one right here is going to be 5/4 plus C2. And now that should be equal to 2. So I'm going to subtract 5/4 on both sides, and C2 is going to be equal to 8 minus 5 3/4. And so I can then write my solution y as a function of x as 1/4 of x minus 1 e to the 2x plus 5/4 x plus 3/4. And that would be how you solve it. And that's that. I'm going to wrap it up here. In the next video, I'm going to continue with the rest of the problems. It's just the one video is getting a little bit long. But thank you for watching, and I'll see you in the next one.